Look at what you have. Yeah, it is long division. Now, how do you see long division? Yeah, because these are the same powers, okay? Or if this is a bigger power. Okay, now I want to show you, like what if I had something like -1 here? Then some people might be like, oh, but this up here is smaller than this down here because this is -1 and this is +1. It doesn't matter. You just look at the powers. Does that make sense? You don't look at, you just look at the leading terms. Don't look at anything else. Okay, if they are the same, then there's a good, well, then you have to long divide. Now you can ignore long dividing if you can bring this up. Does that make sense? If it's a monomial. But see, if I bring this up, remember, this would be x squared plus 1 raised to -1. If I brought that up, and this right here is a family, because we don't break up families in calculus, I would put parentheses there. And do you see, you can't distribute this. You think you can, but this -1 prevents you from distributing. Okay, you can't not distribute. Okay, so because of that, you would have to long divide. Okay, but I just need to tell you, if you had a monomial down here, what's a monomial? If you only had one term, you would want to bring it up. Does that make sense? Bring it up, change the sign, keep the family, and a monomial will distribute, but a binomial will not. Okay, if you bring it up. All right, so let's go ahead and long divide. Okay, put your thinking caps on. Let's do this. You can do it. Here we go. When I long divide, what two terms do I look at first? Right, just the first terms. Okay, just the first terms. And then I ask myself, x squared times what gives me x squared? 1. So you'll put 1 there. Okay, then you multiply 1 times this whole thing right here. So 1 times x squared plus 1 is what? X squared plus 1. Okay, then I subtract. And the subtraction part is where we get in trouble. Because when you subtract, you have to subtract this whole thing. Don't take it vertically, okay? Only a few people can do this thing vertically, all right? You want to do it horizontally. It's like sleeping. Some people can sleep vertically, but most people can't, okay? So you want to go horizontal on this. All right, so if I go horizontal on this, what's x squared plus x minus x squared plus 1? What is that? Using real algebra, not the fake stuff. Real algebra, what do you get there?
X squared plus x minus x squared minus 1.
What isn't that what this is right here? I'm just writing it horizontally. What is that? Is it x plus 1? No, it's x minus 1. Very good. Okay, so there's what a lot of students would do. They'll say x plus 1, but it's not. It's x minus 1. All right, I'm done with that. Then what I do is what? Oh, actually, you tell me what I do. Then what do I do next? Bring down the 1. But when you bring down the 1, you don't just bring down 1, right? Because that's what you did in grade school, but you're not in grade school anymore. You're in algebra now, or even more. You're in calculus now. So bring this thing down, and it's a plus 1. So guys, what's my, what do I have left here? X. Okay, so that's just x. Then I say x squared times what gives me x. But do I need to do that? No, why not? Yeah, because this power is lower than this, okay? So this answer will be plus the remainder, so the remainder is x, over this whole thing, x squared plus 1. Also, make sure you brought down all of your terms or used up all your terms, and I did. Okay, so my answer up here. And guys, be careful, because BC took this test already. And what some of them did is they did this, and then they're like, that's the answer. Is that the answer? No, you actually have to zip your pants. Does that make sense? Like you think you did so much work that you think you did the calculus, but this right here, guys, wasn't calculus. This was algebra, okay? Advanced algebra, but it was still algebra. All right, so now I'm gonna do the calculus part. Now I thought I got to do one problem, but guys, take a look at this. Oh boy, I get to do 2, all right? This is your day. Okay, what is the integral of 1? Right? Is that right? What's the integral of x over x squared plus 1? What's the integral of that? What's the integral? Skylar, what are you working on? What are you working on? You are? Okay. Oh, okay. I was just wondering what you were working on. Okay. What's the integral of x over x squared plus 1? Okay, yeah, check out. Okay, if I make this my u, the derivative of this is what? 2x. Now the question is though, using real algebra, not the fake stuff, do my x's cancel out? X over 2x. Yes, what does it cancel out to? 1/2. Okay, so what I have is 1/2 ln of the entire bottom, but I had to take the derivative of the entire bottom. Make sure you did that if I think it's an ln problem, plus c, and bam, that is my answer. Can you do that by yourself? Okay, I think you can. All right, let's look at this problem. All right, first the question is, can we do the shortcut on this? Okay, so if I just look at the trig part, do I have an integral of tan on my formula sheet? Yes, I do. Okay, pull out your formula sheet if you need help with this, all right? But make sure you memorize it before your test. Remember, the integral of tan is really, tan is really sine, right? Tan 3x is really sine over cosine. Okay, and we said the way you get the tan formula is an ln formula. So what you do is you do the ln of this bottom, okay? Because really the derivative of cosine 3x is 3 sine, I think it's -3 sine 3x, and our sines cancel out, okay? That's why the derivative of ln is negative. So it's negative ln of cosine, right? It's a denominator. This is sine over cosine. It's always a denominator. Cosine 3x, okay, do you have that memorized? All right. Now what do I do though? Let me show you the number one wrong answer. Number one wrong answer, okay? What's wrong with this answer? Yes, you have to divide by the derivative of the inside. So the derivative of the inside is 3, okay? All right, so the answer should be -5/3. You guys good with that? -5/3 ln cosine 3x. Okay, so let me put in the thirds here. -5/3. Okay, this is the right answer. Okay, this will make your teacher happy. All right, any questions on that? And let me just talk about what I really would have done. I really would have taken the derivative of this, put it over here. Does that make sense? Make sure all my x's cancel out. If they don't cancel out, then this is not a shortcut method. Everybody good with that? Then you have to go back and find something else for your u. Now this problem isn't on your test. I'm gonna, oh no, I'm not saying that. I'm not saying, I don't know why I said that. Okay, this problem might be on your test, okay? I'm gonna write this problem. Let me see if I do this right. Tangent, I'm going to make this a squared, tangent 2x dx. Okay, if you see this problem, okay, which might be on your test, okay, this is where students get confused. People will say that this is on your formula sheet, but I want you to look at this. Look at all the trigs. Do you have a secant squared tangent on your formula sheet? Do you have a secant squared tangent? Okay, if I took this off, do you have a secant tangent on your formula sheet? Yes, does that make sense? So you can use a shortcut here, okay? But do you have a secant squared tangent on your formula sheet? No, so you cannot use a shortcut here. Do you guys see the difference? Okay, so this one you could not use a shortcut. So what that means is if I make this my u and I make this my u, meaning I make the argument my u, that is not the way to do it because this is not on my formula sheet. Secant squared u, tangent u is not on my formula sheet. Okay, so if you had this problem, you can't do the shortcut method. And guys, some of you guys are like, wait, I can't do the shortcut method, so I can't do it at all. That's not true. You just went through a whole, you didn't know the shortcut until today, right? Or yesterday. So if you don't know the shortcut, what do you do? What do you do, guys? You do the long cut, which is called what? U substitution. You just do U substitution. So you go figure out which one's your U. This one's kind of the trick problem. Remember we said 2x is in our U. So actually our u is either going to be this or our u is going to be this, one or the other. Okay, you have to rewrite it to see what your u might be. Most of the time it's the one with the higher power, but not in this case. This would be your u, okay? You take the derivative of this, okay? What is the derivative of tangent 2x? What's the derivative of tangent? Do you remember? Secant squared, okay? So secant squared u, okay? But you know how integrals you divide by 2? Guess what you do at derivatives? you times by 2. Does that make sense? So this would be times the derivative of this right here. And a lot of times I'll put the 2 in the front here, just so I don't accidentally pull the 2x from the secant squared family. That's just because I don't like to break up families, okay? All right, and then dx here would be, now see I have this 2 here, so this is over 1. You would cross multiply, but then you would solve for dx, and if I cross multiply and solve for dx, I'll get du over 2 secant squared 2x, all right? Then you substitute 2 things. What 2 things do I substitute? Because it's called U substitution after all, okay? So what 2 things do I substitute? My u and my dx, okay? And so, sorry, I don't need to do that. Okay, so then if I didn't circle it, I won't substitute it. So I rewrite this secant 2x quantity squared, okay? This tangent 2x is my u. This dx is du over 2 secant squared 2x. I ask myself, do my x's cancel out using real algebra? Yeah, they do, because secant squared 2x squared and secant squared 2x are actually the same things. So what do I have left? Can you guys see it? 1/2 u du, okay? Is this an easy antiderivative? Yes, what is the antiderivative of u? Is it u squared over 2 plus c? Okay, what is 1/2 times u squared over 2 plus c? U squared over 4 plus c, and that is a great answer. It is the wrong answer though. Okay, now let's see if we can go back. What is our u in this problem? Tangent 2x. So squeeze that in there. Tangent 2x quantity squared over 4 plus c. And this is the most missed question, I think, for this unit. So just FYI. We've already done this. This isn't a new thing, but you start getting all confused because you're doing shortcuts, okay? So just FYI. All right, let's do another problem. This one. Can I do the shortcut on this one? I can. Do I have on my formula sheet, if I make this my u, do I have on my formula sheet a secant u? Yes. Okay, what is the integral? Now the big problem is, what is the integral of secant u? This is that long one with the plus sign. Very good. So it's the log of secant u, but we're just going to put in our u because we're doing the shortcut, plus tangent u plus c. And those of you guys who think that all these formulas are overwhelming, you know, it's just because you haven't gone into a closet, okay? You just need to take some time, okay? Take your formula sheet, go into a closet, turn on the light, and memorize this, and you'll be like, oh, that wasn't so bad after all, okay? Try it, all right? All right, guys, now what do I have to do, though? This is the most common, actually, some people just throw a 2 here. This is the most common wrong answer. It's wrong, okay? What do I need to do? There's my u. Okay, when I'm doing derivatives, I have to multiply by the derivative of the inside. Well, guess what I have to do if I'm doing integrals? You have to divide by the derivative of the inside. What's the derivative of 7x? 7. Okay, but you have to ask yourself, do your x's cancel out here? Do they? Audrey, can you put your phone away? Do they cancel out? Yes, there are no x's. So this answer is what? 2 7s times this whole ln. Okay, can you guys do this on your own? You feel comfortable with it? Okay, so what we're going to do today is we're going to review our e's, okay? And on the left side here, we're going to take the derivative. And on the right side here, we're going to take the antiderivative, okay? Actually, before we get too far, well, I'll talk about our formula in a second. Let's just go ahead and do this. Let's do derivative, okay? If I wanted to take the derivative, so that's y prime. If y is equal to e2x, and I wanted y prime, what would be the derivative of this? Remember, the derivative of e to the u is e to the u du dx. It sounds like there should be more, but there's not. Okay, so it's e to the u du dx. So this is my u. Is everybody good with that? So it's e to the u, so you copy it, times, guys, what's du dx? Isn't that just a derivative of u? So what's the derivative of u? 2. Okay, and just like on the trig rules, I usually pull my 2 to the front so I don't accidentally multiply it. Really, I pull it to the front because it just looks nicer that way. Okay, do I need Charlie here? Do I need Charlie? No, Charlie, it does not show up in derivatives. Is everybody good with that? All right, so guys, if the derivative of e to the 2x is 2e2x, then what does that mean the integral of 2e2x is? E to the 2x. Well, how do you get e to the 2x from this? You divide by the derivative of u. Do you guys see that? So if it's an e to the u problem, okay, you can say, hey, I think this is an e to the u problem. If it is, now you have to identify it as an e to the u problem. And this is what I mean. If you say this is an e to the u problem, you're calling this your u. Don't change your u. Okay, if you say it's e to the u, what did you say was your u? The exponent, right? Okay, so if you do an e to the u problem, that formula is actually, well, let me just walk you through it. You would copy this, you would copy it, then you would divide by the derivative of 2x. What's the derivative of 2x? 2. Then you do the same thing you do with your tangents and secants and whatever. You would say, do my x's cancel out right here? Do they do? What do they cancel out to? Yeah, well, 1. And so there's your answer. Of course, you could leave that 1 alone if you wanted to, okay? So let's go to formulas and make sure you understand. The derivative of e to the u, the derivative of e to the u is actually e to the u du dx. Make sure you know it's multiplied together. That's the derivative of e to the u, okay? The integral of e to the u is kind of a little bit stranger. The integral of e to the u, though, is e to the u plus c. Why? Okay, why is it e to the u plus c? The reason is because this is using u substitution, okay? Now, if I don't use u substitution, if I want to do the shortcut, okay, and shortcut is called pattern recognition, okay, that's the shortcut. If you want to do the shortcut, this is not your formula. So please pull out your formula sheets, okay? Go find the integral of e to the u du. Go find that in your formula sheet. We're going to add that in, okay? This is a formula using u substitution, but I want you to put both formulas in. If you use u sub, this is your formula. If you do pattern recognition, okay, then what you're doing is you're doing e to the u dx. I need you to understand that, okay? If you're doing pattern recognition, you're not doing e to the u du. You're not trying to match up u substitution here, okay? This answer is going to be e to the u divided by u prime plus c. Okay, it's different. You have to manually go in and divide your u prime, just like all your trig functions that we just did yesterday. If you use the shortcut, so this right here is the shortcut, you have to manually go in and enter this thing. In u substitution, you don't have to, because you take the derivative in u substitution. Here, you have to divide by the derivative. Okay, so let's talk about how that looks. So let's go back to this problem that you had earlier. The problem says, what is the integral of 2e2x dx? And you're going to hate me for this, but I need to help you with this. What you do for this problem, if you're doing u substitution, I know some of you guys are like, I'm not going to use u substitution, but the problem is sometimes you get confused. And when you get confused, u substitution is always right, okay? And so guys, if I think this is an e to the u problem, so you have to think that. I have to say, okay, I think this is an e to the u problem. Then that means this is my u. Does that make sense? Okay, so if this is my u, I would say u is equal to 2x. Then I take the derivative of this. Okay, u substitution always works. Then you solve for dx, force this into a fraction, cross multiply. I'll get dx is equal to du over 2. I replace two things. Now remember, this is already circled. What two things do I replace? My u and my dx, I'm going to circle them, okay? When I replace them, I don't touch anything else, only the things that I circled. So this becomes 2eu times, and what is my dx? It's down here, du over 2. And I ask myself the same thing you always ask yourself in u substitution. Do my x's cancel out? Do they? Yeah, there are no x's, which is great. Do my 2's cancel out? Yeah, that's even better, okay? So what I have left here is integral of e to the u du. Is this an easy antiderivative, or is this on my formula sheet now? Because you just put it on your formula sheet, right? Yeah, it's on your formula sheet. And if you look at your formula sheet, this answer is e to the u plus c, and there is a great answer. It is the wrong answer because u is 2x, right? So you would come back and put in 2x plus c. And do you see you got the same answer as when we walked backwards, when we did the shortcut? Do you guys see that? Okay, so here's the question. Do you want to go with the u sub or do you want to go with the shortcut? You want to do the shortcut. Okay, but you promised me that you'll always divide by u prime. Okay, so let's try. And your x's have to cancel out. So let's do some more problems then. If your x's don't cancel out, then it's not going to work. Oops, I'm going the wrong way. Okay, so let's go back to your problems here. All right, so let's look at this one. Okay, if you took the derivative of this, okay, let's review. If you took the derivative of this, what would be the derivative of e to the u? 2x plus 5 times what? E to the u. Okay, make sure, guys, this is in parentheses. The derivative of e to the u is e to the u du dx. Everyone got that? E to the u du dx. All right, which means if I take the antiderivative of this, do you guys see this is here? I should get this back. Everybody good with that? Because derivatives and antiderivatives are opposites of each other, inverses of each other. Okay, so how do I go from here and get the antiderivative? Well, it's just like you did on your trig problems. You said, okay, I'm going to say that this is an e to the u problem. If I make this my u, is this on my formula sheet? Do I have an e to the u on my formula sheet? Do I have? Yes. Okay. So I have an e to the u on my formula sheet. So what I do is, what is the derivative of e to the u? I'm sorry. What is the integral of e to the u? The integral of e to the u is e to the u. So you copy it. Does everybody get it? We're doing it just like we do the trig problems. You go find your u. Then you look at this and you say, okay, this is on my formula sheet, e to the u. Okay. What is the integral of e to the u? It's e to the u, but don't forget, you have to divide by u prime. Okay, you have to divide by u prime, and your x's have to cancel out. Okay, so here's u. What's u prime? 2x plus 5. So everything else sitting next to this e's got to divide out. Using real algebra. Guys, using real algebra, does this cancel out? Yes. So this is just 1. Oops, I don't need the integral anymore. This is just 1 times, and don't forget Charlie. Okay, so is everybody good on the shortcut? Okay, so sometimes it's hard. You have to decide what it is that's the major function that you're taking the integral of. So let's look at this one. Well, let's look at this one right here. Guys, what is the derivative of e sine x? The derivative of e to the u is e to the u du dx. So what's this going to be? E to the u. What's the derivative of sine x? Do we remember? Cosine x. All right, I'll put parentheses there, just so we don't, actually, we should put parentheses here, just so we don't think that x is being multiplied by the e. I guess yeah, it's really unclear where you would take the cosine of. So actually, I should have put parentheses there. Okay, so here's the question. How do I do this integral? Now make sure you guys understand. You could do this 2 ways. You could do this. Okay, I could put this in this order, right? Or I could put it in this order. If it's in this order, I could do what I did yesterday. Okay, what did I do yesterday? I said, hey, cosine x is on my formula sheet, right? Cosine x is on my formula sheet. If I make this my u, is cosine u on my formula sheet? Do I have a cosine u on my formula sheet, an integral of it? Yes. Then I would say the integral of cosine u is sine u. Okay, this is just like we did on our warm-up. But you have to divide by the derivative of u. So what's the derivative of x? 1. Do my x's cancel out? Do my x's cancel out here? No. Do you guys see that? So I have to figure out another u. Do you guys see that? Do you see that this problem is the same as this problem? Okay. It's just you have to pick which one is that leading u that you're going with, right? So if I pick this one, if I said, okay, let's look at this one here, and I pick this as my u, do you guys see how I pick different u's here? Okay, so I come up here and I say, okay, now, even though these are the same problems, this one didn't work because my x's here did not cancel out. Okay, I go pick another u and I say, okay, look at this e to the u. Is e to the u on my formula sheet? Do I have something on my formula sheet called e to the u? Yes. Okay, what is the integral of e to the u? It is e to the u, right? That's the integral of e to the u. If you look at your formula sheet, the integral of e to the u is e to the u. But you have to divide by the derivative of your u. What's the derivative of sine x? Negative or positive? positive, derivatives, positive. Do my x's cancel out here using real algebra? They do. So this answer actually works. And don't forget Charlie. Okay, you guys feel a little more comfortable with it? Okay, so let's do some regular problems. Okay, so we're going to go down to this e to the 3x plus 1, if I can find it. And let's see. You guys see if you can do it. What would be the integral of e to the 3x plus 1b? And you can do the shortcut or you can do u substitution, whatever floats your boat. Yes, you did. Nice job. Nice job, Sam. Okay, so right here, I'm going to do it the long way. I know you guys are going to hate me, but I'm going to do it the long way just so you guys can see. I'm going to say this is an EU problem. Okay, that makes that my u. If you take the derivative of this, you get 3. If you solve for dx, you get du over 3. If I substitute two things, what two things do I substitute? My u and my dx. So this becomes the integral of e to the u times, and here's my dx down here, du over 3, okay? And then this is u substitution. So I pull out all my scalars, and then I say, hey, is this on my formula sheet, or is this an easy antiderivative? Is this on my formula sheet? Yeah, I think it is. So the answer would be 1/3 e to the u plus c, which is a great answer, okay? But if I put this on my test, I need to put in my u, which is 3x plus 1 plus c, and that is the right answer. Okay, that is u substitution. Okay, so I need you to see that you can do it either way, whatever floats your boat. Those of you guys who are doing the shortcut, okay, did you get the same answer? Did you? Then you're in good shape, okay? And the shortcut goes like this. You look at your problem and just box that in, bracket it in, circle your u and say, hey, is this on my formula sheet? Is the integral of e to the u on my formula sheet? It is. The integral of e to the u is e to the u, but you need to go in and divide by the derivative of your u, which is 3. What number is really here, guys, that you can't see? Do my x's cancel out? Yes. And I forgot Charlie. And I get the same answer. Do you guys see that as u substitution? Okay, so now I'm going to stop doing u substitution, but I wanted you to see that it worked. I'm going to come here. I'm going to pick e to the u as my kind of my main function, and I'm going to call this u. Okay, then I think to myself, is that on my formula sheet? Do I have an integral of e to the u on my formula sheet? Yes, and the integral of e to the u is e to the u. Is everybody good with that? Okay, then you take the derivative of your u. What's the derivative of a negative x squared? Negative 2x. Do my x's cancel out? Why, yes, they do. What do I have left? Negative 5 halves. Don't forget who? Charlie, and we're in good shape. You guys got that? All right, let's do another one. Okay, they're about to get really fun. Okay, so here we go. We're going to try this one down here with the 7x squared. Okay, you guys go ahead and do that, and then I'll check my work with yours. Okay, so I see this as an e to the u problem. It is on my formula sheet, so I say, hey, the integral of e to the u is e to the u, but this is pattern recognition, so I'm going to divide by the derivative of my u. The derivative of x cubed plus 2 is 3x squared plus anything? No, plus 0, right? Do my x's cancel out? Yes. So did you guys get 7/3 e to the x cubed plus 2, and did you remember Charlie? Okay, nice job. Okay, so things can get a little bit scarier. So let's look at this problem right here. Yes, yes, I meant more fun. Okay, sorry, I need to not say everything that I'm thinking. So let's look at this right here. This is really the same problem, but what do you guys need to do before you do this problem? Move the x up. And if I move the x up, what does it become? And guys, what would this become actually? Make this one easier to understand. Because you can't take the derivative like this. What do I need to change it to? Nice. Do you guys see that sometimes you need to rewrite? Are you guys good with that? And this is why your algebra 2 is so important. You learned all of this rewriting in algebra 2. Okay, this is my e to the u. Okay, and I think to myself, do I have an integral? If I call this u, do I have an integral on my formula sheet that's e to the u? Yes, and the integral of e to the u is e to the u. So I copy it. Then I say, what's the derivative of this u? What's the derivative, guys, of x to the negative 1? You have to do derivatives and integrals together, so try not to get confused. Negative x to the negative 2. Nice. So this is negative x to the negative 2. Do my x's cancel out? Yes. What do I have left? Negative 1. Or you can just say negative, because it's negative 1 times this. Don't forget Charlie. Nice job, guys. Okay, do the next one by yourselves. I think you can do it. The sine x one. Okay, some of you guys don't show your work. Like I'm showing my work here. I guess my work is kind of weird. It's just symbols. But it really helps, guys, if you show your work. Because what you do is I'm blocking out things that I shouldn't be touching. Does that make sense? And that helps me to divide by the derivative correctly. So if I call this an e to the u problem, now you got to call it. You might be wrong. So you got to call it. It might not be an e to the u problem. You'll see in a second. They're not all e to the u problems just because it has an e to the u in it. Okay, the integral of e to the u is e to the u. Everybody good with that? But you have to divide by the derivative of your u. So what's the derivative of cosine x? What is the derivative of cosine x? Is it negative sine x? Right? Okay, so negative sine x. Guys, using real algebra, what does this cancel out to? Negative 1 plus Charlie. You guys good with that? Okay, so now let's look at the next problem. We're going to combine things that we know here. So let's look at this problem right here. Okay, now when you look at this problem, you think it's an e to the u problem, but I'm going to show you that it's not. So let me show you why. Let's move this up. So I'll have 1 plus e to 2x, negative 1 e to the 2x. You guys good with that? Okay, so then I'm going to go, okay, guys, this right now here is not an e to the u, so I can't grab that. Let me grab this. This is an e to the u, right? This is an e to the u. This is not an e to the u. You can't just grab like a part of this. You got to grab the whole thing. So this is possibly an e to the u. And then I'm looking at that and I'll be like, okay, the integral of e to the u is e to the u. And then I need to divide by the derivative of my u, which is 2. Do my x's cancel out? No. Okay, so this is not how you do the problem, meaning it's not an e to the u problem with this as e to the u. Guys, any suggestions on this problem? U substitution. What would your u be? Because obviously, when we say it's an e to the u, that's our u. So 2x can't be it. So wiping out the 2x, what else might be my u? Yeah, probably this or this, right? One or the other. And usually take the higher power, or I would say the bigger one if you can. So make your u equal to 1 plus e to the 2x. That's the whole secret, actually, figuring out the right u. Because if we made this our u, guess what the derivative of this is? What's the derivative of 1? Okay, what's the derivative of e to the u? E to the u du dx, right? So that would be 2e 2x, right? Do I put Charlie here? Does Charlie go on derivatives? No, silly. Charlie doesn't go on derivatives. Okay, and then you need to solve for dx, okay? So dx is equal to cross multiply. You force this into a fraction. So this would be du over 2e 2x. Is everybody good so far? Okay, what two things do I substitute, guys? What two things do I substitute? Circle them. My u and my dx. So this becomes, if I didn't circle it, I'm not going to substitute it. And guys, those of you guys online, make sure you understand this, even those of you guys in class, this is essential. Like this step right here, this is what I need to see on your paper to give you partial credit, okay? And also, if you don't have this, I won't even give you credit for the answer, okay? Because you can look up the answer. So this is the essential part that tells me, hey, you really know U substitution. Yeah, Audrey. Oh, well, okay. Well, you're jumping ahead of me, okay? But you want to teach Audrey? No, I'm just kidding. No, I'm just kidding. No, I was going to do the shortcut after I did this. Okay, so here's a question. Do all my x's cancel out? Yes, they do, okay? So the e2x's cancel out. So what I have is 1 over u times du over 2. Now that is super complicated looking. How do I uncloud this? Yeah, pull out the 1/2. Okay, question. Is this an easy antiderivative or something on my formula sheet? What the heck is the integral of 1 over u du? That's ln of u. So it's 1/2 ln of u plus c. Bam! I got a great answer. It is the wrong answer. What is my u in this situation? 1 plus e to the 2x plus c. And I hope you guys are super comfortable with u substitution, because I need to tell you, u substitution always works. Now, Audrey talked about some sort of shortcut here, but I thought we had said that you can't do the e to the u shortcut here. So what shortcut could she possibly be talking about? The ln shortcut. When you make your whole bottom your u, can you divide on the top here? The derivative of your whole bottom, right? So what's the derivative of 1? 0. What's the derivative of e to the 2x? 2e to the 2x. Now, using real algebra, not the fake stuff, do my numerators cancel out? What does it cancel out to? 1/2. So this is 1/2 times the ln of the entire bottom plus c. And did I get the same answer as when I did u substitution? Nice. And it was a lot faster. Although now you feel better about it, don't you? Like you feel like it really works. Yes, sometimes I lie to you, and you never know when I lie to you. So you want to make sure that it really works. All right. So let's try this problem here. Is this an e to the u problem? No. What kind of problem is this? It's a shortcut. What shortcut is it though? ln shortcut. Okay. ln means you're telling me make the whole bottom my u, take the derivative of this. What's the derivative of x squared plus 1? 2x. Do my x's cancel out at the top? They have to, guys. They do. What do I have left here? 1 times the ln of the entire bottom plus c. And if you're uncomfortable with that, okay, you can always do u substitution. I'm telling you, u substitution will always work, okay? So if you're uncomfortable with that, okay, you'll get something like this for u substitution, and you'll get the same answer, okay? All right, let's do another one. This e to the x over 1 plus e to the x. Did we see that already? This one over here. I want to see the difference between this problem and this problem. Do you guys see these two problems? Okay. This problem over here on the left, what do you suggest that we do? Hey guys, can you guys get your videos on, please? Okay, thank you guys. All right, so over here, what would your u be here? Would you bring this to the top? Would you say 1 plus e to the x times negative 1 e to the x and try e to the u? Would you do that? Because then this right here would be your e to the u. So the derivative, I'm sorry, the antiderivative, the integral of e to the u is e to the u. Divide by the derivative of x, which is 1. Do my x's cancel out? Oh, darn. What do I do here? The x's don't cancel out. It's not an e to the u. What kind of problem is this one? U substitution. What are you going to make your u? The whole bottom? Okay, so if you make your whole bottom your u, can I use the ln shortcut? Yeah. Okay, so what's the derivative of 1 plus e to the x? The derivative, so you can write this. Even if you're not using u substitution, you can write this. The derivative of 1 is 0, right? What's the derivative of e to the x? E to x times 1, right, which is just e to the x. So this is e to the x. Do my x's cancel out up here? Do they? Why, yes, they do. So I have a 1 left over, and we said The u was the entire bottom. So that's 1 times ln of the absolute value of u, actually, which is 1 plus e to the x plus c, and bam, we're done. You guys good with that? Okay, let me come over here and show you the number one thing students do wrong, and you tell me why. They look at this, they're like, oh, yay, fraction, ln problem. The derivative of this is e to the x cancels out, yay. That's 1 times ln of 1 plus e to the x quantity squared plus c. Nice. I broke up the family. Guys, when you say that this is an ln shortcut, you have to make what your u? The entire bottom. Okay, you can't just pick and choose. If you say this is an ln problem, then you've picked the whole bottom as your u. So let's take the derivative of this whole bottom. That's a chain rule, right? 2 times, leave the inside alone, take the power down by 1, multiply by the derivative of the inside. So the derivative of 1 is 0. The derivative of e to the x is e to the x times 1, okay? If this is an ln problem, then I need all my x's to cancel out. So look at your numerator. Do my x's cancel out using real algebra? Does this cancel out to a number? I mean, the e to the x's certainly cancel out, but do all my x's cancel out? No, guys, not an ln problem. Is everybody good with that? Okay, so remember, if you do this on your test, I'm allowed to pour water on you. Okay, so please don't do that. Okay, you have to actually make your u what in this problem. So obviously this is not my u. So what's my u going to be? The key is just parentheses. What's my parentheses? Okay, 1 plus e to the x. So this has to be a u substitution problem that you don't have a choice. What's the derivative of this u? 0 plus e to the x, right? Solve for dx. Okay, you substitute two things. What two things do you substitute? Your u and your dx, okay? If I did not circle it, I will not touch it, okay? So this is e to the x. This right here I said was my u, that's why it's circled. This right here is a squared, so I copy it. This right here is dx, dx is right here. This is du over ex. And once again, guys, this right here is the key on your test. You need to have this on your test so I can say, yeah, I know you did not use any other internet resources. Okay, this thing right here, all right? And then I ask myself the question, do my x's cancel out? Do they? Yeah, they do. Using real algebra, guess what? These e to the x's cancel out. So I get 1 over u squared. Remember, they cancel out to 1. They don't disappear. Things in math cancel out to 1 or 0, okay? Things on social media just cancel, okay? But right here, you have to put in a 1, and this is 1 over u squared du. Now I'm kind of stuck. Is this an easy antiderivative, or is it something on my formula sheet? It's actually not on my formula sheet, right? Because this is on my formula sheet, but this one's not. So, but is it an easy antiderivative though? Because it doesn't look easy to me. It is easy. What do you have to do? Yeah, move that 2 up, move the denominator up, and it is an easy antiderivative. Guys, this is not the same as 1 over u du. That's on your formula sheet, but 1 over u squared is not on your formula sheet. And so I'm going to add 1, divide by -1, so I get u to the -1 over -1 plus c. But that's the same thing. Let me move this over here. That's the same thing as negative u to the -1 plus c. But that's the same thing as -1 over u plus c, okay? And that is a great answer. Actually, this is a great answer too, okay? They're just wrong answers. What is my u in this problem? 1 plus e to the x. So make sure you plug in your u, and bam, now I have the right answer, okay? Let's move to this right here. Now that you know the derivative, and guys, this is going to be on your test, this as a review question, these kind of limits, okay? You have this formula on the front of your formula sheet somewhere. It's the definition of a derivative, and we've done this before, okay? This right here, when you see this h goes to 0, okay? it's probably, I mean, sometimes they're tricky, but I won't trick you, okay? It's probably a definition of the derivative. So what is this? This is f prime of x. Like when you see this, you right away write f prime of x. Okay, so what you have to do is find f prime of x. If you can find the derivative of f, then you found the problem. But the problem is you need to find f of x to find the derivative. Do you remember this? So we always pulled out the f, then we take the derivative of f, okay? Sometimes you have to plug in a number, and then that's your answer. Okay, so if you look at this problem here, what is my f of x? What is my f of x here? Look at the formula. This is f of x plus h minus f of x. That's the formula over h. So what is my f of x here? E to the x. What's the derivative of f of x? E to the x, okay? And so, and they're not plugging in any number for this x, it's just an x. So this answer is e to the x. Do you guys see how that works? Okay, let me do another one for you because you might see different ones. I don't know what you'll see on your test. What if I said, what is, let me do, okay, what if I had this on your test? Okay, I have this on your test. What's this answer? Can you quickly tell me? Not x squared, but you're close. It's the derivative of x squared, which is 2x. Can you guys do that? No, it'd just be 2x because, do you see why? Because a negative is part of the formula. Does that make sense? So the f of x is just that. So that's actually a good point. Because if this were a positive, this would be a negative. That's kind of tricky though. Okay, because if this were a positive, then your function would have been x squared and your derivative, oops, sorry, your function would have been negative x squared and your derivative would be negative 2x. Okay, sometimes you'll, actually, I have seen that a lot, but I don't know that I'll try to trick you that way. But guys, make sure you understand, first you pull out the function, okay? Then you take the derivative, okay? And that's what goes here. It's a derivative. It's a definition of the derivative. It's not the definition of the function. Is everybody good with that? Okay, it's a definition of the derivative. All right, let's look at another problem. What would I do if I saw this problem? What would you do if you saw this problem? Okay, well, you can cry. Everyone can cry, okay? But what would you do after you cried? And we have Kleenex all over the room because of that, because we're in calculus. But what would you do? I mean, what if I made this my u, make the whole bottom your u, what's the derivative of e to the 4x? 4e to the 4x, nice, I like that. Okay, I want you to look at this, 1 plus e to the 4x over 4e to the 4x. Do my x's cancel out? Using real algebra? No, they actually don't using real algebra. You can't cancel out this because it's a plus sign. Does that make sense? And even if they were switched, you can't cancel out. So this is not an ln problem, not an ln problem. But remember what I told you guys, if there's a monomial on the bottom, what can you do? You can move it to the top. You guys good with that? So what would happen if I move this to the top? I would get e to the negative 4x times, remember this is a family, we don't break up families in calculus. 1 plus e to the 4x was there before e to the negative 4x arrived, okay? So that is a family. Now let's talk about it. Let's distribute this, okay? What's e to the negative 4x times 1? E to the negative 4x. What's e to the negative 4x times e to the negative 4x? Oh, I'm sorry, e to the 4x. What's negative 4x? Because if the bases are the same, you add the exponents, right? So what's negative 4x plus 4x? 0. So you have e to the 0. What is e to the 0? It's 1. So this is e to the negative 4x plus 1 dx. Another way to do this is, do you see the heart here? Do you guys remember that in pre-cal? Some of your teachers taught you that. I don't know. If you have an iHeartMath, then you can do a common denominator. That's really 1 over 4x plus e to the 4x over e to the 4x. And I don't know if you see that. That's the same as what we have here. Okay, so you could do it either way. All right, guys, you thought you got to do one problem, but check this out. Check this out. Oh boy, you get to do 2. All right, so this right here, what is the integral of e to the negative 4x? close. That's the derivative. Close. Guys, if I make this my u, okay, then guys, what's the integral of e to the u? It's e to the u, right? But don't forget to divide by the derivative of negative 4x. What's the derivative of negative 4x? Negative 4. Do my x's cancel out here? Yes. So do you see you have a negative 1/4 here? Plus, what's the integral of 1, guys? X plus c. Is everybody good with that? All right. I need to look at your homework. But guys, we're just going to do e to the u, not a to the u today. So if you guys have a to the u on your homework, that won't be part of your homework. Okay. Guys, what time do we get out of here?
11:17.
Okay, so yeah, like maybe 1 minute. Guys, the next two problems, you're going to take this and move it up. You guys good with this? So this will be x to the negative 1 over 1 plus x dx. Okay, like this. You'll distribute this. And so this will be x to the negative 1 plus x to the 0. The x to the 0 is really what? 1. Okay. You'll take the integral of x to the negative 1, which you know how to do this. You subtract 1, wait, no. You add 1, divide by 0, ding, 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 ding. Both bells are ringing at the same time. Okay. And yeah, the Ellen bell and that, and you'll do that. Okay, guys, let me take a look at your homework real quick. Let me tell you which ones to omit, but I can also put it on Schoology. Do 1 through 13, 14, do 1 through 14. Okay, so 1 through 14 is what you need to do. All right, guys, make it a great weekend. See you, Paula. Are you talking? Yes, go ahead, Paula.
What about the homework from last night if we didn't show you yesterday?
I'll look at it on Monday. You're fine. I'm not going to pull grades this weekend, so you're okay.
Have a good day.
Bye, Sydney. Have a good weekend. You too, Karina.
There you go.
Hey, bye, girls. Have a good weekend. Hey, Sophie, you ready for your test? When are you going to take it?
What?
When are you going to take it? After school or during?
Right now?
Oh, you want to take it now? Okay. Yeah, let's do it. Do you want to pull a desk out?
Yeah, I can do that.
I can do it for you. We can just pull that last one right there. Does that make sense? I don't know who sits there, but they'll be fine. Please leave your phone in here, Sophie.
Hey, may I go to the restroom?
Yes, you may. I'm going to take your chair. Sophie's going to test.
You can't be having homework.
No, you have more time for homework. What is that? What is Fun Friday? Is that something from elementary school?
Fun Friday.
Oh, thank you, Sophie. Okay. All right, nice. The one over you. Do you understand it?
Yeah.
Okay, good. All right, you got your, okay. So just want to make sure, I'm really grading your work and then making sure that it progresses right. So there's some weird blanks here. Like you might see some weird blanks. Don't worry about it. I mean, it might help you. If it helps you, great. Okay. But if it doesn't, I'm looking at your steps. Okay. Uh-huh. Hey, Fifth Period Online, how are you guys doing? Let's see, Logan, Andrew, can I see your faces, please? And we're gonna print our notes. Hopefully you've already printed them. Go through some shortcuts. We don't have a formula quiz in here. Your test, guys, is on Wednesday though, so we'll get your review on Monday. I'll probably post it up this weekend if you guys want to look at it early.
Are you ready for the weekend like me or what?
I'm so ready.
You got anything fun planned?
Yeah, I'm grading BC tests, like 70 of them.
That's really fun.
Yeah, real fun. And then like I do the same thing I do every weekend. I ponder if I'm going to quit my job or not.
Are you serious?
I'm half serious. No, I think my job's really fun. It's just
You could never quit
the
this.
Schoology,
Take care of it.
the Schoology thing is just nuts. Like trying to manage Schoology. So
Yeah,
let's see.
no, it'd be terrible. You have to stay here forever, Miss Jane.
I'll just have to stay until you guys graduate,
Yeah,
right?
fair enough.
Okay, guys, pull your homework out, please. Your homework should have been, most of it was checked, right? Let me see. Who's still got homework? I need to check. So let me see. I think I might have checked. Miles, do you have yours? And Catherine, do you have yours? Caroline's not here. Okay. Christian, do you have yours? Can you show me yours? Is it? Gracias. Christian. Okay. And then Miles, do you have your log and trig one? Okay, nice. Thank you. And then, oh, wait, do I have another one or you're good? Johnson. Oh, yeah, I got two of them. Yeah, there's two of them. Okay. And the one over you one. Okay, this one, and then this one's just a front one. Okay, got it. And then Catherine, you have, yeah, just the log and trig one. Okay, nice. Thank you. Okay, I think I got everyone else's homework in here.
I don't want y'all to come with me. I go myself. I'm not 4 years old.
Sophie, it's loud out here. It's loud out here. I know. Okay, guys. Let's get started. What we're going to do is we're going to do E to the U today and A to the U on Monday. We'll have a review on Tuesday and your test is on Wednesday. If you want a sneak peek of your review, it might already be in Schoology. If it's not, I'll get it on the up this weekend. Your homework, guys, you picked up a worksheet outside. It's 1 through 14 today. Okay, 1 through 14. And then Monday's homework will be 15 and on. So make sure you understand. Oh, did I put 15? Let me see. Can I see? It's 1 through 14. Okay, I did this wrong.
That's due Monday.
And that's due Monday. And then the rest will be due Monday night or Tuesday morning. Okay? Okay, so let's look at some review questions. And there's another question I want to do that's not part of this review question. So let's see, take a look at this. But I'm going to add it in because we're going to start to get confused a little bit and with the shortcut. And I want to make sure that you guys understand when you're allowed to use the shortcut and when you're not. And we're going to add another U sub and possibly a shortcut too if you want to do the shortcut. Okay, so let's look at this problem. How would you approach this problem here, the integral? I mean,
Long divide.
long divide. Now, what keys you off that you have to long divide? This power is 2 and this power is 2. If they are the same powers, or if this one's bigger, you ignore everything else, okay? Don't just look at the leading terms. That doesn't necessarily mean the first term, right? But the highest power term. And if they are the same power or the top is bigger, then you're going to have to long divide. So let's look at this problem here. All right, so x squared plus x plus 1 divided by x squared plus 1. Let's do it, guys. All right, nice. X squared times what is x squared? 1. Everybody good with that? Okay, then 1 times all of x squared plus 1. So what's 1 times x squared plus 1? X squared plus 1. Okay, now we subtract, but it's a lot easier to subtract if you subtract horizontally. It's kind of like sleeping. It's a lot easier to sleep if you sleep horizontally. Okay, so we're going to pull this horizontal so it's easier to understand. All right, so this is going to be, I'm getting x minus 1. Are you getting x minus 1? Okay, I got it because Parker said it, I think. X minus 1. Are you guys getting the same thing? Okay, so then what do I do next? Bring down your negative 1 or your positive 1. And this is algebra, okay? So you can't just bring down the 1. You have to bring down plus 1. So it's x minus 1 plus 1. Okay, that's just x. Do I keep going? No, why? Also because this power is lower than this power. Does that make sense? Once this power is lower, then you're done. So you're going to add what to this, guys? X over x squared plus 1. Nice. And that is your answer. Don't forget Charlie. But don't we have to integrate? Yes. So I have to tell you, be very careful because we've done so much work. We think we've zipped our pants, okay? But guys, zip your pants, okay? So yeah, we haven't even done the calculus. So make sure you do some calculus, okay? All right, so let's look at this problem. This problem should be 1 plus x over x squared plus 1 dx. And we thought we got to do one problem, but guys, check this out. Oh boy, you get to do 2. What's the integral of 1? X. What's the integral of x over x squared plus 1? Ooh, nice. If you're making this whole thing, the whole bottom of your u, take the derivative of this. What's the derivative of x squared plus 1? 2x. Now, guys, the x's have to cancel out though, and you have to use real algebra. X over 2x, what does that cancel to? 1/2. So it's 1/2 ln. It is an ln problem if you made your whole bottom of your u and the x's cancel out. So this is ln of x squared plus 1 plus Charlie, and that is a great answer. Can you guys do that on your own? I think you can. All right, so let's look at this problem right here. We showed you the shortcut on here. Do you want to keep on doing the shortcut or do you want to do a long cut? Okay, if we do the shortcut, then you look at this problem and you say, okay, make this my u. Okay, guys, make this problem very clear. In your formula sheet, do you have a tangent u? Because if you don't, you can't do this shortcut. Okay, you do have a tangent u. So since I have a tangent u, what's the integral of tangent? Very good. Even more than cosine, I think it's a negative, right? So negative ln cosine u, but now my u is 3x plus c. And this is the number 1 wrong answer. Okay, yes. And then actually the number 1 wrong answer is this. You put in the -5. That's still wrong. What am I forgetting? Yes, you need to divide by the derivative of your u. If you're doing the shortcut, you have to manually go in and divide by u prime. If you're doing u substitution does that for you, okay? That means I have to manually go in, divide by the derivative of 3x, which is 3, and so I get negative, well, it's just 5/3, but there was already a negative here. And so it's, let me make sure you understand. It's 5/3 times negative ln. You guys good with that? And then, so what is 5/3 times negative ln? Negative 5/3, okay? All right, nice. I think you guys are good at this, but I don't want you to get confused, so we're gonna keep moving on this. All right, this integral right here, I want you to change it for me. Well, actually, just do it, do this one. What is the integral of secant u? What's the integral of secant u? Okay, that real long thing, right? The secant plus tangent one, good. So it's gonna be the ln of secant x plus tangent x plus Charlie. Okay, number 1 wrong answer. People put a 2 here and they're like, I'm done. I'm good, I'm done. You're done, but you're not good, okay? So what is this u here? 7x. What's the derivative of u? You have to manually go in and you divide by u prime if you're doing the shortcut, okay? I know it's not written anywhere, but if you're doing the shortcut, that's what you have to do. So what I want to do now is I want to do this problem with you, and I want you to understand how this one, I'll do 7x tangent 7x, is different from this one, secant squared 7x tangent 7x dx. And you've already been tested on this. Unfortunately, it's a hard problem and people have trouble with it, okay? When you look at this problem, if you make this your u, do you see there's two u's here? Okay, is this on my formula sheet? Do you have a secant u, tangent u? Yes, okay. Look at this one. If I make this my u, is this on my formula sheet? Do I have a secant squared tangent? No, okay. So since this is on my formula sheet, you can do the shortcut. Does that make sense? Okay, so let's do the shortcut here. What's the integral of secant u, tangent u? Secant 7x, right, secant u. But don't forget to divide by the derivative of 7x, which is 7. And then do my x's cancel out? Yes, so this is 1/7 plus c. Okay, do you guys see that? Over here, since there is no secant squared tangent u on your formula sheet, this is not your u. This is not the shortcut. Is everybody okay with that? What would be the long cut then? That just means that's not your u. What else could be my u possibly? Tangent. So guys, for this problem, tangent x is your u. And if you wanted to rewrite the secant squared, you can also, but actually the tangent's going to be your u here, okay? And you would take the derivative of tangent. Now, a lot of students have trouble with this, but now that you know the integral is you take the integral and divide by 7, guess what this is? You take the derivative, but instead of dividing, you're going to multiply by 7. That's what the derivative is. So the derivative of tangent u is secant squared u times, do you remember what? Times du dx. Okay, if you look at your formula sheet, that's what it will say too. All right, so I'm going to move the 7 to the front just because I don't want to accidentally multiply by that 7x. That is a 7 actually. Okay, solve for dx. I would get du over 7 secant squared 7x. Okay, I substitute two things. What two things do I substitute? My u and my dx. If you did not circle it, you do not substitute it. So this becomes the integral of secant 7x quantity squared times, that's my u right there. My dx is right here. So this would be du over 7 secant squared 7x. And those of you guys who are doing your test, this right here on your test, this is the key. This is how I know that you are doing u substitution correctly. If you cannot show this step, then I can't give you full credit. I might give you 0 credit, even if your answer is right. Because this tells me, especially for those of you online, that you're not using any internet resources, okay, that you know a lot of things. This tells me that you know a lot of things. So here's the first question. Do my x's cancel out? Yes. So these are the same things, even though they don't look exactly the same. So what I have is u du over 7. Well, that's really strange. Now I'm in trouble. I thought this was supposed to be on my formula sheet or something that's an easy antiderivative. Take out the 1/7, okay? Take out the 1/7 and things will look a lot nicer. Is this an easy antiderivative? Yes, this is 1/7 times u squared over 2 plus Charlie. And if I combined it, you could say it's 1 over 14 u squared plus Charlie, and that is a great answer, okay? It's just the wrong answer. Make sure you go back, find your u, wherever it is, okay? Put that u back in, okay? And there's your right answer. So be careful. You cannot always use the shortcut. Do you see the difference, okay? Make sure it's actually on your formula sheet. Okay, so we're gonna go to a review, and then we're gonna do our e to the u's. Okay, so guys, what is the derivative of e to the u? What is the derivative of e to the u? Let's do this. The derivative, so this is on your formula somewhere. And actually pull out your formula sheets because we're gonna put the integral in. It's e to the u du dx. It's kind of sing-songy, you know what I'm saying? It's sing-songy, except it seems like there should be more to the song, but there isn't, okay? So it's e to the u du dx. What is the integral of e to the u? Go find your formula sheet, please. We're gonna put in the integral of e to the u du, okay? And this formula is e to the u plus c, okay? So go find your formula sheet, and that is your formula for e to the u. Okay, but maybe you want to put this on your formula sheet, maybe not, it's up to you. But if you do pattern recognition, your formula is not this. If you do pattern recognition, okay, what you're doing is you're not changing to u substitution. You're leaving this as a dx. if you do pattern recognition, your formula is this. And maybe you want to put it on your formula sheet, maybe not. It just depends on, do you understand? If you're using U substitution, you would use this formula. If you're doing the shortcut, okay, you're going to do this formula. Okay, and we did that for the trig formulas too. Okay, so let's see how this works. You have these problems here on your notes. Okay, what's the derivative? We're going to do derivative on this side. What's the derivative of e to the u again, guys? E to the u du dx, right? And it's all times. So it's going to be 2e to the 2x. You guys good with that? Okay, what about down here? What's the derivative of e to the u again? E to the u du dx. So the e to the u just means you copy. Okay, you copy the e to the u. It's e to the u, but then you have du dx. So it's a derivative of this exponent, which is quantity 2x plus 5. You guys good with that? Actually, can you guys put parentheses here? This is much better with parentheses here. This cosine x. Okay, so what about this? Y equals e sine x. What would be the derivative of that? E to the u du dx. So this is the e to the u, right? You copy it. And what's the derivative of sine x? Cosine x, okay. So do you see I have the answers on this side, right? And the derivatives on this side. So that means the integral of this should be that, right? The integral of this, right? The integral of this should be that. And the integral of this should be that. Okay, so we're going to talk about how we can do the integrals to get this back. Okay, so what's the difference between this right here, and the one without the 2? It doesn't have a 2. How do I get rid of that 2? Here I multiply by 2. Guess what I have to do here? Divide by 2. Here I multiply by 2x plus 5. Guess what I have to do here? Divide by 2x plus 5. Okay, so the way you do this is this formula. Do you guys want to do, actually what I'm going to do is, I'll do pattern recognition here, but down here I'll do U sub and pattern recognition, okay? So the way you do this is first you copy your e to the u. Okay, actually what you do is this, you say this, here's my function, I'm going to make that my u, just like you did for your trig problems, right? Like if you had secant 7x, you said, okay, there's my function, I'm going to make that my u. Then I say, is this on my formula sheet? Do I have an integral of e to the u on my formula sheet? Yes. What's the integral of e to the u? E to the u, right? The integral of e to the u is e to the u. So then I say, okay, copy e to the u. Then you need to put in that extra step because I'm doing pattern recognition. Divide by the derivative of 2x, which is 2. Do my x's cancel out? Yes. So that's 1. So my answer is e to the 2x plus c. Do you see pattern recognition? Okay, like let's do this one. This one I'd say, okay, I'm going to make this my u. Okay, you have to choose your u. If I do that, look at this problem and say, okay, do I have on my formula sheet an integral of e to the u? Yes, okay. What is the integral of e to the u? It's e to the u. Yeah, so the integral of e to the u will be e to the u, so you just copy it, okay? But since I'm doing pattern recognition, I have to divide by the derivative of my u. So what's the derivative of x squared plus 5x plus 7? Do my x's cancel out? They have to, yes. So this is 1 times, and there is my answer, but add Charlie. You guys see that? Okay, let's do the last one, and I think you guys got the hang of this. If I make this my u, and you have to choose what's your u, okay? If you make this your u, okay, what's the derivative of, well, is this actually just e to the u? Is that on my formula sheet? Yes, okay. So what's the derivative, I'm sorry, what's the integral of e to the u? E to the u, but you have to divide by u prime. So what is the derivative of sine x? Be careful. What's the derivative of sine x? Is it positive or negative though? Positive. So you divide by cosine x and you ask yourself, do my, not counting your e to the u, do my x's cancel out here? 1. So there is your answer. Okay. So what I'm going to do now is I'm going to do u sub. I know you think you're never going to do u sub, but I want to point out to you that sometimes you get confused, and then u sub will be helpful, okay? So I take a look at this, and let's say I forgot how to do pattern recognition, okay? What I'll do is I'll say, hey, wait, I think this is an e to the u problem. If it is, let me make this my u. If I make this my u, okay, then the derivative of this, what's the derivative of sine x? Cosine x, right? Then my next step is to solve for dx. You force this into a fraction, guys. Force it into a fraction, solve for dx, okay? Then I substitute two things. I substitute my u and I substitute my dx. So I'm going to circle them. If I don't circle them, then I don't put any, then I just copy them. I don't substitute anything. Okay, so what I have is the integral of cosine x times e, and okay, this is my u, right? This is my u right here. So e to the u, my dx was down here. So that's times du cosine x. Okay, and once again, those of you guys who are at home, if we're doing u substitution, this is what I'm requiring you to see. Then I ask myself, do my x's cancel out? Yes, okay. And so then my answer is the integral of e to the u du. Is this an easy antiderivative, or is it something on my formula sheet? Okay, it's not an easy antiderivative, actually. It's on my formula sheet. I guess it is an easy antiderivative, but I've got e to the u du. I guess I'm saying it's an easy, like, reverse power rule. Does that make sense? It's not a reverse power rule. So it's on my formula sheet, which is e to the u plus c, and that is my answer. Okay, except it's the wrong answer. Go back and put in my u. And so do you see u substitution works? Okay, if you get confused, u substitution works. Now I want to show you something. What if I gave you this problem, but I switched the e and the cosine? So what if I said the integral of e to the sine x cosine x dx? Do you agree that it's the same problem? Is everybody good with that? Okay, what you do is you'd say, okay, because usually you go on the right side, right? Usually you go on the right side and say, okay, make this my u. Make this my u. Do I have an integral of cosine u on my formula sheet? Tyler, do you mind putting that away? Do I have an integral of cosine u on my formula sheet? Yes. What's the integral of cosine u? Sine u, right? Okay, positive or negative? Positive. Okay, then if this is my u, what's the derivative of x? 1. Do my x's cancel out? No. So that means u is not x. Does that make sense? That means go find another u. And it turns out, you know, you have to swap these to actually get your u to be sine x. Does that make sense, guys? Okay, so if you pick the wrong u, all you do is go back and find another u. Okay, this class is all about finding who you really are. Okay, let's see another problem. Yeah, actually, it's mostly just about finding, can you do calculus or not? But I was trying to make it kind of pretty. Okay, look at this problem. At first glance, this looks really hard. Okay, but let's take a look at this. This right here, I take a look at this, I bracket it in, and I circle this, and I say, this is my u. Okay, then I say, hey, is this on my formula sheet? Do I have an integral of e to the u? Yes, okay. So the integral of e to the u is e to the u. What's the derivative of my u, though? You have to force that in. 3. So I'm going to divide by 3. Now, this is kind of weird, but do my x's cancel out? Yes. What actually scalar do I have here? 1/3 plus Charlie. Do you see how hard this looks, but how easy the problem is? Okay, let's go to another problem. What if you have this problem? Okay, you guys do it. Go for it. Now, if I call this an e to the u problem, okay, the integral of e to the u is e to the u. But if I divide by the derivative here, what's the derivative of this u? Negative 2x. Do my x's cancel out? What did you guys end up as a scalar? Nice. Okay, let's do another one. This one down here. Okay, you guys can do this. The 7x squared one. Did you get 7/3 e to the x cubed plus 2 plus Charlie? Did you get that? Nice. Okay, go to the one across from that. How in the world would I do this problem? Very good. When you move the x squared up, what do you get? Okay. You're actually going to have to change this too. What is 1 over x? X to the negative 1. And do you see this problem is doable, whereas this one would look just terrible. Okay, so sometimes it's just a rewrite. All right, this is going to be my e to the u. Okay, the integral of e to the u is e to the u. But don't forget, you have to divide, because you're doing a shortcut method. You have to force yourself to divide by u prime. So what is the integral of x to the negative 1? Or the derivative, sorry. Negative x, the derivative of this is negative x to the negative 2. Do my x's cancel out? Yes, what do I have left? Negative. Nice, okay? Let's skip the next one. I think you're good with the next one. Let's go to this other one that looks like a fraction over here. This one right here. Let's do this one. You guys good? We'll just move this up. You want to do that? Let's move that up. 1 plus e to the 2x. That would be negative 1 e to the 2x dx. Okay. This is an e to the u problem. Okay. The integral of e to the u is e to the u. Divide by the derivative of 2x, which is 2. Do my x's cancel out? No. That's not good. We used the wrong u. So if the u is not 2x, what is the u going to be, do you think? It's the whole bottom. Okay, try it. If it doesn't work, we'll just use another u. You guys are good at u substitution anyway. If this is your u, so your u is going to be 1 plus e to the 2x. The derivative of this, what's the derivative of 1? 0. What's the derivative of e to the 2x? 2e to the 2x. Guys, force this into a fraction. Solve for dx. So if I force this into a fraction, I cross multiply. Dx would be equal to du over 2e2x. I replace two things. I'm going to go ahead and circle it. If I don't circle it, I'm not going to replace it. All right. So this will be the integral of e to the 2x over the bottom here is going to be u. This dx here is going to be du over 2e to the 2x. I ask myself the question, do my x's cancel out? Do they? Yes. So what I have left is 1 over u times du over 2. This looks terrible. What in the world is this? I'm supposed to have an easy antiderivative. Pull out the 1/2. You guys good so far? Pull out the 1/2. Is this an easy antiderivative or something on my formula sheet? It is. What is it? Well, let's pull it up. This would be 1/2 the integral of u to the negative 1, right? Add 1, divide by ding, 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 ding. Did you hear the ln bell? Okay, so what is this? What is the integral of 1 over u du? Ln of u plus Charlie, and that is a great answer. It's just the wrong answer. Please make sure you come back in and you put in your u, which is 1 plus e to the 2x plus c. Did anybody wonder why we didn't do an easier way? Did anybody see an easier way? Guys, go back up here and look at this. Did I make my whole bottom my u? Did I? If I make my whole bottom my u, what am I allowed to do? I can take the derivative of the whole bottom, which is, what's the derivative of 1? 0. What's the derivative of e to the 2x? What's the derivative of e to the 2x? 2e to the 2x. Do my x's cancel out? Okay, what number do they cancel out to? 1/2 times what? The ln of the whole bottom plus c. Did I get the same answer? Yes, very nice. Okay, so FYI, if you realize that you took the derivative of the entire bottom, you can do the ln shortcut. All right, so let's do another one. Not that one. Let's do this one. Okay. And guys, I just want to tell you, you do enough e to the u problems, you forget how to do the other problems. You do enough trig problems, you forget how to do the other problems. So we need to keep rewinding. Okay. So how would you do this problem? Ln shortcut. Make this your u. What's the derivative of x squared plus 1? 2x. Do my x's cancel out? What do they cancel out to? 1. This will be 1 times the ln of the entire bottom plus c. Very nice. Okay. What about this one? Is this an ln shortcut? Okay, look at these two problems. One's on your right side, one's on the bottom left of your worksheet. One is an ln and the other is not. Do you see it? Okay, the left is an ln. So let's look at this one. If I make the whole bottom my u, what's the derivative of 1 plus e to the x? E to the x. What does my numerator cancel out to? 1. So this will be 1 times ln of 1 plus e to the x plus c. And that was really nice. Remember, guys, this is a shortcut, but it only works if 2 things. Your whole bottom is your u, and the x's cancel out, okay? Guys, look at this problem. I'm going to tell you guys what students do here, okay? They look at this and they're like, oh boy. Actually, it's not an oh boy problem, but they're already on the wrong track because they're saying oh boy, okay? And then they look at this and they think, okay, I'm going to make the bottom my u. I'm going to divide by the derivative of my bottom. Let's see, the derivative of my bottom is e to the x. So that's 1. So this is 1 times ln of 1 plus e to the x quantity squared plus c. Bam! That's my answer, okay? Why is this wrong? I did the derivative of the bottom. I didn't do the derivative of the whole bottom. Does that make sense? Okay, so if you do this right, if you say this is an ln problem, what you're doing is you're saying this is your u. Do you see when I take the derivative of this? It's a chain rule. So that would be 2 times 1 plus the inside times the inside raised to, take the power down by 1. Don't forget to multiply by the derivative of the inside. Look at your fraction on the top. Okay, using real algebra, not the fake stuff. Do my x's cancel out? One of them do, but do all of them cancel out? No. So this is not your u. You have to start all over. So guys, if you have a problem like this, how would I do it? You could bring the bottom up. I'm not sure that's going to be helpful because I'll show you why. Because see, this is a -2 now, and then you still can't distribute because of this -2. Now, had it been a 1, you could have been okay. So that's not going to be too helpful. Guys, you go back to u substitution. Sometimes you have to do u substitution, okay? Sometimes there's no shortcut method. Guys, look at this. What's your parentheses? What's your parentheses? 1 plus e to the x, okay? What's the derivative? E to the x. What's dx going to be? Du over the e to the x. What 2 things do I replace? My u and my dx. If I didn't circle it, I'm not going to replace it. See, I didn't circle that squared, okay? So you can't replace that squared. And this dx is now du over e to the x, and I'll replace that. And guys, those of you guys who are doing tests online, this right here is the key. I need to see this step, or I cannot guarantee that you did not use the internet, okay, or some other resources, okay? Right here, I'll ask myself, do my x's cancel out? Do they? They do. I get 1 over u squared times du. Now I ask myself, is this an easy antiderivative or something on my formula sheet? Now, just a warning, it looks like it's on my formula sheet, but if you go to look at your formula sheet, you have a 1 over u, but you don't have a 1 over u squared, okay? So it's actually not an ln problem. It's an easy antiderivative. You just have to move that 2 up, okay? You're going to add 1, divide by -1, so you're going to get u to the -1 over -1 plus c, which is actually the same, which is actually the same thing as negative u -1 plus c, right? Because if you divide by a negative, it's just a negative. And this is the same thing as -1 over u plus c, and bam, okay? That is a great answer. It's just the wrong answer. Make sure you come back in, put in your entire u, okay? And that is the right answer. Okay, so we just did which one? Okay, now we got the limit problem. Guys, this is coming back on your test. This test on Wednesday, okay? This is a review of the derivative, okay? Guys, if you see a limit, h goes to 0, okay, you really should just say, that's the definition of a derivative. Everybody good with that? Guys, is this a definition of a function? Did we ever learn anything called the definition of the function? No, this is the definition of the derivative, okay? And guys, the formula for the definition of the derivative is right here, okay? This is your f of x plus h. This is your minus sign. This is your f of x. And this is your h, okay? So guys, what you do, and you've done this before, is you pull out the f of x. Then you take the derivative of it. Sometimes you plug in a number, sometimes you just plug in x, and that's your answer. Is everybody good? Okay, so in this problem, what is my f of x? Okay, so f of x equals, not negative, because do you see this is a negative already? Does that make sense? So it's just e to the x. Okay, so this is e to the x. What's the derivative of e to the x? E to the x. So what's the answer right here? E to the x. You guys good with that? Okay, let me give you another problem, see if you can do it, because I don't know what problem will be on your test. So what if I give you this problem here? I'm just gonna make up a problem. Okay, what if I give you this? Okay, 2x, very nice. Okay, why? Because this is your f of x. Does that make sense? What you want to put here is your f prime of x. Let me just talk about this, make sure you understand. The number one wrong answer is x squared. Does that make sense? Because that's your f of x. But remember, you're trying to find your f prime of x. So you need to take the derivative of that. So this answer should be 2x. Is everybody good with this? It's the definition of a derivative. It's not the definition of a function. Okay, let's look at this problem. Okay, ideas, guys, ideas. Let's do this. What if I make this my u? What's the derivative of e to the 4x? Isn't it 4e to the 4x? Okay, let's look at this, guys. Okay, remember, real algebra, not the fake stuff. Do my x's cancel out there in the numerator? No, they don't. They would if I didn't have this 1 plus, okay? But this 1 plus prevents me from canceling, okay? So this is not an ln problem. What kind of problem is this? Bring it up. Bring it up. This one will help. Anytime you have a monomial down here, there's a good chance that when you bring it up, happy things will happen, okay? So I'm going to bring it up. All right. Well, that didn't help. First, I had a quotient rule, which I couldn't do. Now I have a product rule that I can't do. How does that help? You distribute. Guys, when you get stuck on these things that look like product rules, okay, you distribute. What is e to the negative 4x times 1? E to the negative 4x. What is e to the negative 4x times e to the 4x? Close. You add the exponents. So what's negative 4x? What is negative 4x plus 4x? Isn't that 0? Okay. But what's e to the 0? 1. Okay. Dx. All right. Now, you thought you got to do one problem, but check this out. Oh, boy, you get to do 2. Now, it's been a long time, I mean, probably about 30 minutes since you've done a problem like this. How do you do e to the negative 4x, the integral? What's the integral of e to the negative 4x? You take the, okay, so is this on my formula sheet? Do I have an e to the u on my formula sheet? Okay, what's the integral of e to the u? E to the u, but don't forget, you have to divide by the derivative of your exponent. What's the derivative of negative 4x? Okay, so I'm going to divide by negative 4. Do my x's cancel out right here? Yes, but what does it cancel out to? Negative 1/4. Very nice. So hopefully you can do this. What's the integral of 1? X. Don't forget, Charlie. Okay. All right. Let's look at this one right here. Okay. So how do I do this problem? Okay, bring it up. So this would be x to the negative 1 times the quantity 1 plus x dx. Guys, 1 plus x is a family. It was a family before x to the negative 1 joined it, okay? Keep it a family, guys. You would not multiply x to negative 1 just by one of them. It has to multiply by the whole numerator, okay? Now I'm stuck. I had a quotient rule. Now I have a product rule. You distribute, okay? If you can. If you can't, then go back to the drawing board and figure out another u. So I'm going to go ahead and distribute. What's x to the negative 1 times x to the 1? You add the exponents. You guys good with that? Because this really has a 1 here, right? 1 plus negative 1 is 0. But what's x to the 0? 1. All right. You thought you got to do one problem, but guys, take a look at this. Oh boy. Okay, you get to do 2. What is the integral of x to negative 1? You add 1, divide by ding, 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 ln. Okay, so do you see that this is really just 1 over x? Oops. This is really 1 over x, the integral of 1 over x, which is ln of x. Hopefully you're comfortable with that. The integral of 1 over u, right? 1 over u du is ln of u. So the integral of 1 over x would be ln of x. What's the integral of 1? Oops. So that would be plus x, and don't forget Charlie. All right. Okay, let's do the last one together, and then you guys are on your own for 1 through 14. All right. How do I do 1 plus x over x squared? What are your suggestions? Okay, bring it up. That turns the x squared to x negative 2. But guys, this is a family. Don't break up the family. Okay, so I have 1 plus x squared dx. I'm stuck. Distribute. Okay, when you're stuck, do the big D. Okay, I'm going to distribute. So when I distribute, I get the integral of x to negative 2 plus x to the 0 because I'm adding exponents. But what is x to the 0 really, guys? 1. Okay, then take the integral of this. You're going to add 1. You're going to add 1. Divide by negative 1. Okay, so what is that going to be? Negative x to the negative 1, right? And then what's the integral of 1? X. And I'm in good shape. I mean, this isn't the best format. It's not simplified for sure. Okay, but that's a great answer and the right answer. All right, so when you see these square roots, you have to change them. Like you can never integrate with the square root. So that's really x to the 1/2, right? Over x to the 1/2. Okay, so first, don't let those square roots intimidate you. It's just x to the 1/2 and x to the 1/2, all right? So if I made this bottom my u, the derivative of that would be 1/2 x, taking the derivative. You subtract 1, so negative 1/2, right? If I took the derivative. And so do my x's cancel out like that? No, right? Because e to the x 1/2 over 1/2 x to the negative 1/2. I mean, e to the x is not the same thing as x. Okay, so I'm not a u substitution. Okay, get that out of the way. What can I do, guys, when I have a monomial on the bottom? Bring it up. Okay, so what I'm going to do is bring this x to the negative 1/2 up. Then I have e to the x to the 1/2 dx, right? And then you guys think you could take it from here? No? Okay, that was a unanimous no. Okay, let's look at this. This isn't, if I make this my u, do I have on my formula sheet an antiderivative, an integral of e to the u? Right, okay, so what's the integral of e to the u? It's e to the u, okay, but you have to divide by the derivative of your u here. What's the derivative of x to the 1/2? 1/2 x to the subtract 1 here, right? So that's negative 1/2. Can I leave you guys there? Yes. Do your x's cancel out? What do you have left? Now be careful. Yes, you have a divide by 1/2 left, but if you divide by 1/2, you're really multiplying by 2, and there is my answer. Okay, so let's look at number 8, guys. Let's think about strategy here. What do you want to make your u? Okay, think about it. We actually have this choice because numerators and denominators basically are in parentheses, right? And do you see there? Wait, they can't be the same thing. No, they're not, because this has a negative and this has a positive, right? Guys, we're looking at number 8. Okay, hey guys, we're looking at number 8. Yeah. So guys, if we look at number 8, pick which one your u is going to be. What do you think would be a better u, the top or the bottom? The bottom. Does that make sense? Try the bottom. So make the bottom equal to your u. You want the whole bottom equal to your u? What's the derivative of this whole bottom? What's the derivative of e to the x? E to the x. Okay, what's the derivative of e to the negative x? Isn't that e to the negative x times negative 1, right? E to the u du dx. Okay, So if I simplify this, this is e to the x minus e to the negative x. Now, I made the whole bottom my u. Do you want to do the shortcut or do you want to do u substitution? I can do either one. Okay, so if I made the whole bottom my u, do you remember what the shortcut is? You divide by the whole bottom's derivative. So what's the derivative of e to the x plus e to the negative x? E to the x, you told me, it's e to the x minus e to the negative x. Do my x's cancel out there on top using real algebra? Yeah, what does this cancel out to? I mean, it's really e to the x minus e to the negative x over e to the x minus e to the negative x. What does that cancel out to? 1, right? And this is an ln problem. So the answer is 1 times the ln of your entire bottom plus Charlie. Nice job. That's a good problem. Now, maybe you have to tell me what it is, though, but it's like the log e. Is it like, what's this up here in Sophie? Like that? Okay. So remember when you log a tree, the cap falls out. So when this cap falls out, this is equal to the integral of 2x minus 1 dx. So now just do this problem.